Okay, we're here at gotomath.com. Let's click on the calculus and we'll go right down here to concavity and the second derivative test. But first we'll be covering concavity and inflection points. So we want to click on that and go to 1-2. Alright, so it says find all inflection points, and here's a graph of the function h of x, and I've actually got the inflection point, got a dot at about where it's going to be. So we can count over 1 and then up 2, it looks to me like. And of course, if you don't like that, you can click on the button. Click, click, click. Okay, I guess we'll have to do this problem now. Anyway, so here it is. Let's write that down and go to the board quickly. Alright, everybody get that? Well, let's bring up something to write on. Okay, so we have h of x. If I can write neat today. H of x is equal to 3x cubed minus 18x squared plus 36x minus 28. So what we'll want to do is take the derivative, and so we end up with 3 times 3 is 9x squared minus 36x plus 36, and then we're going to take the derivative again. H double prime of x, 2 times 9 is 18, and minus 36. And then what we'll do is set it equal to 0 and solve for x. Okay, so it looks to me like, we'll just write it over here, x is equal to, what, 2? X is equal to 2. So to test if it's actually an inflection point, we would label 2, so this is like our critical number. We would label 2 here and then take a test point like 0 and then a test point like 3, and all we care is if it's negative or positive, right? So we'll plug that into the second derivative, 0, and you'd get negative. So that means that it's concave down from negative infinity to 2, and then we plug 3 in, we end up getting a positive number, and that it's concave up. Okay, so since there's a change in concavity here, that means that there's possibly an inflection or an inflection point. And one other thing, a tangent line must exist at that inflection point, and of course it does. Okay, there is a tangent line at that inflection point. If you took the 2 and you plugged it into the first derivative up here, we would get some number out anyway. But okay, remember that would give us the slope of the tangent line. So we have an inflection point at 2. So it's a point, that means we write it as an ordered pair, and then we take the 2 and plug it back into h of x up here. So h of 2. And I'll let you figure out what that is. Alright, so when I say point, that means there's an ordered pair, right? A location on the graph that we're looking for. So let's go back. So as you can see here, the actual tangent line, if we were to draw a tangent line at this point right here, the tangent line looks like it would be 0. Okay, it would be 0. Alright, and as you can see the graph, this part of the graph is concave down and this part is concave up, and you can think of it as concave up being holding water, right? It's holding water. Anyway, I remember that's the way I remembered it. Alright, you just practice those. Oh, we need to hit the answer, don't we, real quick. 2-4. Okay. Alright, well, come on by and practice that, and I will see you there. Bye.